Okay, let me give you another example here. Imagine you're standing on top of a really tall building. You're going to drop a cannonball here off the building. Oh, by the way, if you drop a cannonball off the building, and let's say you drop a cannonball and a snooker ball off the building, the two will hit the ground at the same time. Okay. Also, that if you drop a cannonball, a snooker ball, and let's say you jump off this building at the same time, all three of you will hit the ground at the same time. It's just one of those strange things that you have to accept. And in one of the earlier videos, a long time ago, I gave you this formula: H equals G T squared over 2. So if you want to find out how long it takes the ball, well, if you want to know how far the ball, the cannonball here has travelled, um, then you would use this formula: H equals G T squared over 2. So after, let's say after 7 seconds, if you want to know the distance traveled, then you would put this into this t here, and g, because we're on gravity, we're on Earth, then the gravity is 9.8. Then you would put 9.8 into the g, and then you could find out the distance traveled after 7 seconds. So if you want to know the distance traveled after 4 seconds, then you would put the 4 into here. Now I've done a video on this, so if you don't understand this, then track it down, track the video down and watch it. But if you want to know the distance traveled, then you would use this formula here. One day I will show you how to how you can get to this formula. Okay, but for time being, just realize that if you want to find out the distance traveled after X amount of seconds, then you would use this formula here. Okay, but hang on, let me show you this here. So suppose you're standing on top of a really tall building, you're going to drop a cannonball. When t equals 0, that means right at the start, the speed equals 0. Okay, and when t let's say a second later, the cannonball is here, so t equals 1. Then the speed would be 10, because because we're on Earth, so the acceleration, well, when you drop a cannonball, the cannonball will accelerate down here at 10, well, at 9.8 meters per second squared. That's because we're on Earth. If you're on the moon, then it will accelerate. If you're on the moon, the cannonball will accelerate downwards at 1.622, something like this, meters per second squared. So it will accelerate downwards at this acceleration here. If you're on Jupiter, it may be 23 point something meters per second squared. So if you're on Jupiter, the acceleration is a lot bigger. So it will fall a lot quicker. Well, anyway, because you're on Earth. We can use 9.8, but let's round it off to 10. So let's use the acceleration on Earth as 10. Okay. If you want a more accurate answer, then use 9.8. But let's simplify things. Let's use time. Sorry. Let's use 10. So when t equals 0, the speed will be 0. So when well, hang on. Hang on. When After 1 second, the cannonball will be here. So after 1 second, the speed will be 10. Okay. After 2 seconds, the cannonball will be here. After 3 seconds, it will be here. After 4 seconds, it will be here. Can you see each time the distance covered, it gets bigger and bigger each time, because each second. Well, because there's an acceleration. Now, if there's an acceleration, then there's an increase in speed. Now, well, if there's an increase in speed, then you're going to cover more ground as time goes on. So as you drop this cannonball, this gap here gets bigger and bigger. Okay, so when t equals 0, speed is 0. When t equals 1, speed is, well, the speed increases each time. Now, if the speed increases, then the distance covered will get bigger and bigger. So here your acceleration time graph will look like this at 10. Okay, so the unit of acceleration is meters per second squared, and time is measured in seconds. So your acceleration time graph will look like this for this this cannonball here. Now the speed time graph here, and remember speed is meters per second, and then time is seconds. Your speed time graph will look like this. And the gradient here is 10. So really it will be, well a straight line which is y equals mx plus c. Well let's use s instead of y. So speed equals, the acceleration is the gradient. Because we're on Earth, the acceleration is 10. So the equation for this line here is 10, s equals 10t. Okay, the intercept here is 0, so we just don't put it in there. So your speed time graph will look like this. Now your distance time graph, okay, well your distance time graph, you can use that formula to work out the distance. So h equals gt squared over 2. Okay, you can use this, or we can use our speed time graph. So after 1 second here, the speed is 10. Okay, the speed is 10 after 1 second. So get this times this. Basically, because we want to know the distance traveled after 1 second, we need to work out the area underneath this graph. So get the height here, which is 10, times 1, and then divided by 2. That will be 5. So after 1 second here, this will be 5. And or you can use this thing here. You can use this, or you can use this. It actually amounts to the same thing, because okay, after 1 second, let's put 1 into this t here. Okay, put 1 into the t. So you are standing up here. You're going to drop a ball, and you want to know the distance traveled after 1 second. So after 1 second, you can use this formula here. This formula is for free fall. So when you drop something of a building, let's say it's going to free fall to the ground. So you use this formula here to work it out. So put 1 into this t here. So h equals g 1 squared is 1. Okay, so 1 squared over 2. So this thing here is 1. 1 times g is just g. Now g, we've taken it as 10, gravity on Earth. We've taken it as 10. So 10 divided by 2 is 5. So it actually amounts to the same thing. Okay, and then after 2 seconds, you can use the speed time graph here. After 2 seconds, the speed will be 20. So now it's 2 times 20, which is 40, and then divided by 2. So after 2 seconds, it would have covered 20 meters. Okay, 20 meters. Or you can use this formula here and put 2 into here, and then h is the distance or the height. H is the distance traveled downwards. So you can use this, or you can use this, and it turns out that your distance time graph will look like this. Okay, yeah. So in order to construct this here, either use the speed time graph, work out the area, or you can use this. So maybe you can plot something like this: t here, and then distance here, and then 0, 1, 2, 3, 4, and so on here, and then use this here to plot this time graph here, and it turns out to be a curve. Well, to find out the distance here, you can either use this or the area underneath the speed time graph. Okay. Yeah, I will explain this, how we got to this formula another time. Okay.